Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at Changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode servers. Head to linode.com/changelog. This episode of Go Time is brought to you by AirBrake. AirBrake is full stack air monitoring for Go applications. Get real-time error alerts plus all the info you need to fix any error fast. And in this segment, I'm talking to Joe Godfrey, CEO of AirBrake, about why getting to the root cause of errors is so important.
Look, Adam, to me, root cause is everything. All software has bugs. We all know that. And when you find a bug or when you can't find a bug, the amount of time that typically gets spent trying to chase around and figure out how to reproduce the problem and what's the cause of the problem, even like what part of the code kicked it off or what sort of actions drive it. I mean, that's hours and hours of time wasted spent chasing your tail instead of actually fixing the problem, improving the customer experience, and getting back to building more features, which is really what your company is all about. So to me, being able to really understand like what is the root cause of this problem is the key factor to being able to solve that problem and get back to doing what's most important, which is building new features and improving your product and quite frankly, fixing the customer experience that's broken as long as that bug is out there.
All right, check out AirBrake at airbrake.io/GoTime. GoTime listeners get AirBrake for free for 30 days, plus you get 50% off your first 3 months. Try it free today. Once again, airbrake.io/GoTime.
I'm Matt Jaffee, and this is Go Time.
This is Go Time, a panel of Go experts and special guests every single week discussing the Go programming language, the community, and everything in between. We record live every Thursday at noon Pacific, 3 p.m. Eastern. Tune in at gotime.fm.
Welcome back, everybody, to another episode of Go Time. Today's episode is number 76. On the show today, we have myself, Eric St. Martin. Carlicia Pinto is also here.
Hi, everybody.
And Brian Kettleson.
Hello.
And our guest for today is Matt Jaffee, who works for Pilosa, working on a open source distributed index. Is that the best way to describe it, Matt?
That's as good as I've heard.
So let's first step into like maybe a little bit of background about you and kind of your history in Go, and then we'll kind of jump into what Pilosa is and what makes it interesting.
Sure. I started playing with Go in early 2015. I joined this company called Humble here in Austin, Texas, and a critical piece of their infrastructure was something that they developed in-house called Pilosa, and it was written in Go. And when I first started learning about it, I thought it was, about the coolest thing I'd ever been close to in my career. And so I immediately decided to start playing with Go, and then quickly became very enamored with the language. And my colleagues will tell you, I started pushing it every chance I could get, internally. And so I led the platform team inside Humble for about a year and a half before we spun out Pilosa as a separate company and have been working on that ever since.
That's awesome. So tell us a little bit about Pilosa itself. And I know it's a distributed index, but there's some properties about it that kind of make it unique. And then we'll kind of talk about like why Go and why Go is a good fit, and maybe even some of the points that you struggle with.
But also tell us what a distributed index is, because not everybody might know.
Sure. So you take a database, right, and it really has two parts. It's got storage, and then it's got indexing, which is basically there to speed up different queries.
Right.
And so with Pilosa, what we've done, and we didn't really decide to do this initially. We just had a very specific problem that we needed to solve. But sort of after the fact, we realized that what we'd done was taken the index part out of the database and made it a standalone piece of software. And so you store data in Pilosa, but it's really just bits of knowledge that encode relationships in data that you use to speed up queries.
So one differentiating factor is, like you said, it's not embedded within the database. But also typical indexes are kind of stored as binary trees and things like that. And from my understanding of Pilosa, it's a bitmap index.
That's correct. B trees and binary trees and such are very popular structures for indexes. And if that had worked to sort of solve our original problem, we probably never would have built Pilosa. But the problems that we were having in Umble were around high cardinality segmentation of, when you have, millions or hundreds of millions of possible attributes across hundreds of millions of items, and you want to drill down to very specific or very complex segments of those things. B-tree indexing starts to fall apart, but bitmap indexing can be very good. So it's my highly biased opinion that bitmap indexes are a highly underused data structure.
So would you say that, like, what's a good use case? Would you say something like faceted search is a good use case for a bitmap index over using like a B-tree?
Well, tell me what exactly you mean by faceted search. I'm not familiar with that term.
So faceted search would be kind of like creating like a taxonomy of your data and searching on multiple filters at once. So different properties. Let's use say a booking engine or something for hotels, right? You want it to have a pool and this and that, and you're kind of looking for these individual features that are a lot of them, I guess, could be Boolean, right?
That's excellent, actually. And we've talked several times about sort of the e-commerce use case where you're looking for a certain item. Maybe it's a TV and you're drilling down, you have on a certain size and a certain resolution and a certain price range. And that is really a slam dunk use case for a bitmap index, especially because it's powering a UI that is very sensitive to latency. If you have a consumer who's digging through something, they don't want to wait a full second or 2 seconds for their query to finish. It's more engaging if they have to wait 50 milliseconds.
So I have a confession to make. I got my start in big data way back in the day, 1990 something, at a company called Omnidex. And they did the same thing, but it was in C and C++. And it was a lot harder to install and maintain than Pilosa looks, I can tell you that. But the same concept, bitmap indexes on data with covered indexes, and most of the queries could be resolved without even touching the data itself. They would be covered by the indexes.
I'm wondering
Oh, sorry. Go ahead, Carlos.
I'm wondering if you have any sort of numbers. So being able to scale the storage independently of the indexing system seems like should be a slam dunk decision, right? It should scale a lot better. Do you have numbers to compare, like data storage combined with indexing, which is the regular, normal, bread and butter relational database, versus separating those two?
Well, so I think that the importance of the index isn't so much storage. It's that a lot of times when you're searching for data in a database, and even in a distributed database, you have to touch multiple machines or seek to many places on disk to find the data to see whether it applies. So by having indexes, you can limit the amount of data that you need to go out and fetch from wherever it's stored.
Yeah, that's a good point too. That's a different, I would say that's a different use case, but I think those are two different use cases, and you can have both, the need for both, right? And I'm sure there are other use cases probably.
Yeah, Carlisia makes a really good point, actually. And I do have sort of rough numbers I can share. We are incredibly delinquent on making some big benchmarking blog post, but typically when you ingest data into Pilosa, the amount of memory or disk space that's taken up in Pilosa is about 1/10 the original data size. And it depends heavily on the cardinality of the data and what fields you're indexing and all that. But an order of magnitude decrease is pretty typical.
Yeah, well, I wouldn't be surprised. And how about complexity of, we actually just had this discussion with a different guest, different system, complexity of installing and maintaining this compared to just the one thing, relational database where everything is there.
There is definitely overhead, when you think about having to maintain more than one system, right? I think the guest you're probably referring to is Cockroach DB. And I mean, wow, that is a fantastic system. I actually would love to do some benchmarks against them at some point. But I think Pilosa, our thesis is that an independent standalone index is going to be an important part of the technology stack in the future. And we see really cool use cases where, somebody just has a whole bunch of big blobs in S3. Maybe they're JSON, maybe they're CSV, whatever it is. And really the only option for querying, these cloud providers, BigQuery type solutions where you're paying per query, and it can get quite expensive. Whereas if you could sort of just index that data in something without moving all of it into another database, you could potentially get extremely good query performance while sort of still having it be very consistent and very durable wherever it is.
Oh, that's actually a really interesting use case I hadn't thought of. If you already have data being stored somewhere that isn't necessarily a database that has its own indexing mechanisms.
Yeah, that's kind of the.
Okay.
I was just going to say that's kind of the power of the standalone index. You don't even have to index flat files or database records. You can index your mailbox. You can index anything that you have data retrieval access to, and it makes for a lot of power that you normally wouldn't see in a regular database because you're only communicating with the index, not communicating with a data store.
Yeah, and let's not forget what powers all the big search engines on the web. Nobody really talks about it, but they're basically giant standalone indexes.
Oh, right. Yeah, that's a very good point.
And fast, too.
Yeah,
so tell us, I'm sorry.
I was just going to say it's kind of mind-blowing when you think about how fast search engines are and the amount of data that they have access to.
Well, that's a good segue into performance in Go. How have you found keeping high performance in your system with indexes and developing this in Go? What kind of stumbling blocks have you found? What kind of interesting tidbits do you have to share for high-speed Go development?
So my first tidbit is to join the performance channel on the Gopher Slack because there are some really, really good people in there. But as far as our personal experience, Go has been amazing. I don't think that we are good enough developers to build this in C or C++. I think we would have failed, right? Because the compile cycles and the memory management and all that stuff, I think you just get bogged down. Whereas with Go, we can have a lot of that taken care of for us. The type system helps us a lot. Interfaces, all this like nice, fancy, modern language stuff. But it also gives you the escape hatches you need when you need to get down and really have super high performance on logical operations on bitmaps, right? And so we employ unsafe in very low quantities, exactly where we need it to get that performance and to keep memory off heap, so that the garbage collector is not bothered by the bulk of the allocations, and you can end up with a really nice hybrid where you get the low level performance advantages of being able to play with memory, but also a lot of the type safety and garbage collection and all those nice high level features.
So do you have to do a lot of work for performance tuning to make the queries faster? Like, are you doing a lot of profiling of the garbage collector and things of that nature, escape analysis and things?
We have done a lot, and I think we will make time for a lot more. Honestly, for a lot of use cases right now, performance isn't a huge issue anymore. I hope we'll find some that really drive us to get down into the millisecond, sub-millisecond latencies. But right now, it has an HTTP kind of REST-like interface, which I'm sure if we just sort of got rid of that and used gRPC or something, we could cut off a few milliseconds right there, sort of our baseline response time. But we've definitely had several sort of deep hackathons on profiling and finding, places where we had easy wins, basically. But there's definitely a lot more to do there, and Go's tooling keeps evolving. The tracer and all the different profiling types you can do. I think we've scratched the surface, maybe scratched it pretty deeply, but we certainly haven't broken through into all of what's possible.
And now, in kind of discussions through email before you came on the show, you had mentioned too that part of the reason that Go was such a great fit was being able to kind of, at least for building a distributed tool, was that you were able to kind of cut out external dependencies like Zookeeper.
Yeah, Go has a lot of good libraries and a culture of making things, pretty tightly packaged and not pulling in lots of dependencies into your projects. And we're trying to sort of follow that culture in Pilosa, and also it's been a great help to us to be able to pull in libraries to do things like cluster membership. And because of Go's concurrency model, it's easy to sort of have that running in the background in the same process without really, blocking anything or affecting latency of queries or anything like that.
It's amazing how much mileage we're getting out of the Raft and membership libraries. It's almost like they're the bedrock of an entirely new generation of distributed apps.
Yeah. These really, really hard problems are almost becoming commoditized now.
Yeah, and that's, between some of the tooling we see like Kubernetes and these libraries for, embedding distributed things into your application, distributed consensus protocols and membership protocols and what's the one I'm looking for? Gossip and things like that. Like, it's really amazing people are actually doing that stuff in Go. And Go almost seems like the language any new distributed systems tool is written in, where I guess Java and potentially C and C++, kind of held that ground for, generations.
Yeah.
So let's talk about exciting stuff that you want to do or would do if given the time in Go. Like what fascinates you outside working on your distributed database?
Oh, let's see. Outside of Pilosa, I think there's a lot of cool opportunity in like the Go build and the AST packages where you can sort of get really easy prepared access to modifying Go programs and analyzing Go programs. I think that's an area where Go's, strict adherence to simplicity is going to allow people, and already has allowed people, to build really great tooling. But I would love to do very project specific tooling where, even though Go has Go Fumped and a lot of really good sort of culture and idioms, every project tends to come up with its own, little ways of doing things. And to be able to enforce those in a tool rather than spending time, reviewers' time in pull requests and stuff is a really great thing. And I think that Go's support for that kind of tooling is in a place where it's probably worth the time to invest in it.
I was wondering the other day whether you could take the AST rewriting and rewrite combined with a compiler, so you'd almost have like a hotspot JVM, but for Go. I don't know enough about all the low-level bits, but it just occurred to me that we're almost there in terms of tooling.
Yeah, and that's such an interesting point, because there are, a lot of really big databases that basically compile your, not your queries, but like the query plan or the query execution on the fly for performance reasons. And Go just kind of got plugins a little bit. We looked at that briefly because there's so much you can do when you have data in a very processable format like you do in a database or an index, and being able to bring processing to that data, complex processing, which has typically been the realm of complex query languages like SQL, but to be able to sort of do that in code and ship that code to the cluster rather than shipping the data to the code, I think there's a lot of opportunities for distributed algorithms running on indexed data in the cluster, at scale, that could open up a lot of opportunities.
I hadn't thought about that in a database context. I know like MemSQL does that now. They compile your SQL statements down to precompiled SQL that they ship out to each of the nodes. So that would be interesting from a Go perspective, because you could almost build a SQL executor that's smarter than just running SQL. You could build the membership and the awareness into the actual precompiled SQL statement. I'm going to have to write that up and play with that. I have to think about that a little bit. It's kind of mind-blowing for me.
I guess the sort of hacky way that you could do it is just call out to the Go compiler and then run a new binary with exec.
Yeah, that's kind of what I was thinking, though. You precompile your SQL statements, and they're just another binary, but the binary has built into it the ability to send the query performance or the query results back to whatever's collecting them. You just build that all in.
Yeah, so you almost have like a runtime for distributed data processing around which you would wrap around your compiled query.
Right. Yeah, I'm going to go build that. I'll be back.
Okay, we'll wait.
Can we get some Jeopardy music, dude?
I'm just going to import 2 or 3 libraries and I'll be done, right?
Pretty close.
This episode of Go Time is brought to you by ActiveState. ActiveState gives you a faster way to build and secure open source runtimes from your first line of code on through to production. Every second you spend building your Go distro or open source language distro is less time spent on doing the work you love. You got better things to do, you know it, I know it, and with ActiveState you can focus on your code and leave the open source to them. Your teams can standardize with Go builds from ActiveState for your specific use. You'll have less friction in the development cycle, and that means you can deliver apps faster. Try ActiveState and see why it was chosen by IBM, Microsoft, NASA, Siemens, PepsiCo, and more. Discover for yourself why millions of developers trust ActiveState to build their open source language distros. Check them out at activestate.com/GoTime. Once again, activestate.com/GoTime.
So first up, there is a new Go conference called Go Northwest that I just saw that's at McCaw Hall in Seattle at the end of July. That's gonorthwest.io. And it looks like it's a community-driven conference. It's $100 to get in. They haven't released speakers, but they have their CFP open.
Nice. I didn't look at the website yet. Is it exactly at the end of the July? Oh, it's the 30th. So that's gonna be really close with Golang UK. I'm sorry, GopherCon UK now. I want to say GopherCon UK is like 1st, 2nd, and 3rd of August. So that's going to be tight.
I just want to say I love this initiative. I think we should have one-day conferences like that around the country, around the world. Just like a local, right? Get everybody from the region. One day doesn't require a big commitment, doesn't require a huge organization.
Absolutely.
We need to have one like this in San Diego.
Yeah, I'd love to see more regional events pop up all over the country, like one day. Well, when I say one day conferences, not like I'd like to see them pop up one day. Well, that too.
I'm going to clarify.
Preferably today.
You're right. Yesterday would have. Well, then I would have missed it. But in Florida, somebody do one in Florida.
No, I just wanted to give a shout out to all the organizers. You guys are awesome.
Yeah, and organizers of meetups.
Yeah.
Brian and I have been terrible meetup organizers.
We should just resign, because between running the conference and our day jobs, we're not doing a very good job of our meetup.
Yeah, coming up with topics and stuff is often hard. So I don't know if anybody else saw this post, but I got really, really excited. As people who listen often, regular listeners might know, like Brian and I love messing with hardware and pretending like we know what we're doing. And I saw this post. It's a part 1 of a series called Go on Very Small Hardware. And this person took a small STM32 like Cortex M0 processor and wrote software using something called MGO, which appears to be like a subset of the Go language. But I will fully admit that I have not got a chance to play with this, and I really want to, just because that's what I've always been torn on is Brian and I play with the Raspberry Pis and Odroids and Arduino, anything that will run full Linux so we can program in Go. But then I also like playing with the small ARM processors and things that Go does not run on. So I'm really excited to be able to try to merge those worlds. And now I have, I sent pictures out, I think over Twitter and stuff, of this embedded board that has a small touchscreen LCD, and it has a Cortex M4 on it that I've been waiting to mess with our barbecue stuff on. And I was going to have to do it in C and C++, but now I may have to play with MGO.
Yeah.
Although I have the feeling that I will have to write a lot of my own direct memory access stuff for the screen if I want it to work.
Yeah, that stuff is really cool. I'm really into mechanical keyboards, and there's all this really good open source firmware. But if you want to hack on it, it's all in C. And keyboard controllers are, those super low memory, like 32K. No way you're putting the Go runtime on that. But the possibility of doing a keyboard firmware in something like MGO, I think, would be really cool.
Yeah, and this hardware is 16 kilobytes of flash and only 4 kilobytes of RAM it was running on, to give you an idea of how small. Yeah.
I got to read that article now. That's impressive.
Yeah, and I'll drop a link to it in the Go Time channel. But I'm looking forward to seeing the rest of this series and getting some time to play with that.
Nice. Our barbecue's getting upgraded.
Right? And in Go, that makes it even more exciting. I wanted to use that low-level hardware to not have to have a full Linux machine running for it. But I really wanted to do it in Go because I'm really into Go. I could do it in C, but I don't want to. So the next... Oh, go ahead.
I was going to say, speaking of the barbecue rig, I may have to get new hardware for mine because it stayed out in a rainstorm the other day, and it's not looking pretty. It's a good thing I just got that new Raspberry Pi 3B Plus or whatever the latest Whatever the latest Pi is, I got a new one, so I might have to replace it. Stupid Florida rain.
Yeah, the rain ruins everything. So another cool project I came across because I think it was last night, Damian Grisky was signal boosting something and was talking about NVIDIA's CUDA and Go. So there is a package, gorgonia.org/cu, that is a CUDA driver for Go. And I think they're looking for help and things to evolve this more. But I guess it was a few years ago I started trying to play with CUDA. I wish I was better at it. But this looks awesome. Now I have more reason to do it because, again, I don't have to do it in C. I can do it in Go.
Boy, that library is huge. Low level, too. Yeah, I remember when we were playing with CUDA, we were trying to build a database with GPUs. Back when we thought we could do anything.
And dear to my heart, not only because, Pilosa, I think, could benefit massively from processing bitmaps on GPUs. It's just such an obvious application. But I've done CUDA in the past. At a previous job, I was writing this software to inspect network traffic on the GPU. So trying to do like 10 gig, like pattern matching and stuff. And it's super fun, but again, the build cycle and the bugs that you run into can be really frustrating when it's not Go.
Yeah. Truth. So I ran across a project that I got super excited about. I'm embarrassed about how excited about I got this project. It's GoTop, and it's at github.com/CJBASSI/GoTop. And it's really just top, but written in Go, and it's written in one of those nice text UI libraries. So you get pretty boxes and graphs, and it's prettier than HTOP, and it's got nice moving text graphs on it. It makes me happy. So, yeah, GoTop. If you like watching the blinking lights, I'll put a picture in Slack and tweet it because it's so pretty.
That looks totally rad.
And while we're talking about distributed databases, DQ Lite is one that I came across too, which basically takes SQLite and turns it into a distributed SQLite cluster. I have not played with it yet, but I think that's cool.
You know what's awesome about DQ Lite? So one of my favorite underrepresented projects is LXD from Canonical and Ubuntu. And the DQ Lite came out of their new feature that supports distributed LXD clusters. So they get this automatic clustering feature now in LXD. And I can't wait to try that too, because LXD is awesome. And having a cluster of them almost gives you a different spin on the whole, like Docker Swarm kind of feel. So I want to play with it because I like LXD. And it was Canonical that came out with that DQ Lite for the purpose of bringing that distributed clustering to LXD.
Nice. I didn't know the history of it.
Now you do.
We need. Where's our sound effects board? We need the more you know. Do little.
I'm here for you.
Hey, Matt. I believe we were promised jokes.
That's right.
Well, no. It was promised I would be funny, but there's no explicit promise of jokes.
Well, that was implied. So
I don't know. I guess somebody asks you for a joke, you never have one ready, do you?
Yeah, and I always wonder if they're appropriate for the occasion. The one that it's like the one that I can remember at that moment in time is not appropriate to the time at all.
All right, I dropped a screenshot of GoTop in our Slack, and I'll put it on Twitter too, because we don't want to exclude people who aren't in our Slack. What other interesting news did we have? Oh, I wanted to mention Micro, my favorite microservice framework, Micro, is now supportable on Patreon. So if you go to patreon.com/microhq, they just announced that this morning, and I was the first supporter. Hooray! I love my Patreon. So go out there and support Micro if like me, you love an easy way to make really powerful distributed microservices systems with very little bit of code. Micro is the way to do that. Go support them.
You know what would be really cool is, how some companies like Microsoft will like match you when you donate to like nonprofits. How cool would it be to have companies match your donation to like Patreon?
I love that whole idea.
Like let's make that a thing.
Let's do that. I'm making a note and I'm putting that in my to-do list. Matching Patreon. All right, it's in. I'll email Satya today and see what I can get.
Just call him up on the phone. You've got his number, right?
Exactly.
All right. So if we don't have any more projects and news, one of the things we like to do every week is give a shout out to an open source project and or maintainers. And this does not have to be Go, but just to make sure that we're showing love. We can do that in verbal form, giving shout outs, or through Patreon. Who wants to go first for Free Software Friday?
I do. Pick me.
All right.
Pick me.
You go first.
All right. So this is kind of meta, and it makes me so happy. There's a project on GitHub called All Contributors, and it's under Kent C. Dodds, Kent C. Dodds org on GitHub, All Contributors. And it's a really neat way to recognize all the people who have contributed to your project beyond code. So you can recognize code contributors too, but you have to go to the repo to really see it. It gives you a really pretty chart that shows you who's contributed to the project and in what way. And those ways might be things like answering questions on the forums, or promoting the project on Twitter, or writing documentation. So it's a great way to recognize the whole community that makes your project thrive, as opposed to just the people contributing code. And I love it so much, I want to adopt it for all my open source stuff.
I absolutely love this. It's great.
Isn't it awesome?
Awesome. And it looks great too. You get a little table with people's picture, not just a list of names.
Exactly. It looks pretty, and it gives you a way to, say hello to everybody, and thanks to all the people who are doing the hard work. So I'll post a link to that in Slack.
And how about you, Carlicia?
I want to give a shout out to Francis Campoy and his Just for Fun project, the video production, and especially the I/O pipes episodes. Figuring out how to use I/O pipes correctly and when to close things, it can be a bit mind-boggling, and he does a great job walking you through different scenarios. That's a great episode. So very grateful that I had that to watch when I needed. And Just for Fun in general, I think is becoming for me at least, a go-to place. Like, I want to figure out how this works. Maybe Just for Fun will have an episode on that. And it's like, yeah, it does.
Carlicia, I don't want you to think that I'm making fun of your accent, but when you say Just for Funk, that's not what I hear, and that just kind of makes me smile.
What do you hear?
I hear something that doesn't sound like funk.
Just for fun?
No.
I think Brian hears something vulgar because he wants to hear something vulgar.
All right. Well, you're gonna have to
tell me. Not because I want to. No.
When we stop recording, you're gonna have to tell me.
I will. Well, I'll say it off air.
I can't even imagine. Okay.
I'm terrible.
And Matt, I know we're kind of hitting you out of the blue, So feel free to say no. But if you have anybody you want to give a shout out to, and like I said, it doesn't have to be a Go project or a maintainer.
Actually, as soon as you guys started talking about this, I quickly racked my brain and went searching. But Carlizia saying just for funk reminded me of the way I feel about all the talks that Liz Rice has given. If you haven't seen any of those, she has one on syscalls that I saw at GopherCon that was just amazing. The depth that she went into about how you can play with them in Go. And she's done stuff on like ptrace and containers. And you always kind of come away with this feeling of like Zen-like understanding of what's going on in the operating system. It's really cool.
I know she does it all off the cuff too. I had to follow her at was it Golang UK last year? And I was so mad. I was like, how the hell do you follow somebody who just goes up there and live codes syscalls in Go on the spot without even preparing for it? I can't follow that. That's why I had to put on a wig at GopherCon UK or GopherCon Russia.
I've seen her talks too, and I have to say, she makes it look so easy. Like, you just do this. It's simple. Like, well, she doesn't say that, but she just goes over it in such a clear and direct and like concise manner. And you think, oh my gosh, this is so simple. But obviously not. But she has a gift.
She's one of my favorite speakers. She's really good.
Yeah, and her and Julia Evans too, with all of the little cartoons she draws on how things
like the
work.
Performance cartoons. I love those.
Yeah. And I don't know how many people have seen the talk she did at Strange Loop. I think it was like 3 or 4 years ago, but it was, I think, something like how to be a kernel hacker, or you can be a kernel hacker. And this is, I think, in C, but she explains kind of how syscalls work and how you can make your own.
Now she's Bork on Twitter, right? With a B0RK.
Yes.
Okay, yeah, go follow her because she just tweets the most awesome, smart stuff.
Yeah, everything that comes out of her feed is like really good knowledge and super approachable.
Yeah, I've got some stickers of how Kubernetes works on my desk over here. I love that stuff. So my free software for Friday for today, I gave away a little bit when I talked about the Go on very small hardware. I really hate trying to say names because I feel like I'm going to butcher them, but Michal Derkacz, something like that, MICHALDERKACZ. Yeah, I'm so bad with names. But anyway, he is Zutek, Ziutek on GitHub, and that is who created the MGO project that we just talked about. So I love him for that right now because I'm excited to play with that. Mm-hmm. But I also love him in the past because he also wrote the MySQL library, which I used the crap out of in my early days of Go doing MySQL stuff. I actually don't. Is it still the most popular MySQL driver? Does anybody know? I haven't done MySQL in a while in Go.
I don't know the answer to that. That's a good question.
Yeah, hit us up.
I've only done Postgres for the last many years.
Surprisingly, I haven't done much SQL database stuff in Go in the last, 3-4 years. I mean, doing things like Cassandra and Kafka and things like that. Yeah. So
I used Michael's Telnet driver to turn it on and off my TV. I think we talked about that on one episode, didn't we?
Oh, yeah.
I have a Go program that turns on and off my TV from the command line, and it's because it's got a friggin' open Telnet port. But I'll never tell you what port it is because you guys can't control my TV.
Nmap.
Good luck getting in.
Will tell me. You do realize who you're talking to, right?
Yeah, come on over. And you have my Wi-Fi password. We're in trouble.
Exactly.
Actually, speaking of Nmap, there's a project that was recently rewritten in Go called BetterCap, which is basically sort of an Nmap clone or network Swiss Army knife kind of thing.
Yeah, and I was really excited about that. I mentioned it a couple of episodes ago, but I'm actually really, really excited about seeing a lot of InfoSec tools written in Go these days. I've seen some clones or advancements in things like Dirbuster and things like that written in Go. I know a couple of people who are pen testers too that have been using Go for kind of like their scripts and stuff like that, and for exploits, kind of moving away from doing it in Python and things like that.
There have been a couple of viruses found in the wild written in Go, haven't there?
Yeah.
That's kind of how you know you've made it as a language.
Yeah, that's not so good.
I mean, arguably, you could use BetterCap, a lot of that stuff, right? There is another framework that has a bunch of that stuff. Yeah, no, BetterCap's the one I'm thinking of because it's got like some Wi-Fi snooping and things like that, password sniffing and things like that are already built into it. But yeah, so you could basically just write a virus and use that to sniff out the stuff you need. But yeah, speaking of the MySQL thing, keep me informed. Like, I'm actually really curious what people who are using MySQL in Go, what library they're using today for that. I want to stay informed. All right. Did anybody have any other shout outs before we call this show complete?
Not for me.
Not for me.
I'm good.
All right. Well, thanks so much for coming on, Matt. This was a lot of fun.
Oh, thank you so much for having me. It's an honor.
And thank you, Brian and Carlicia, as always, for being amazing.
Oh,
and
thank you. You're so generous.
That's what I do.
And definitely shout out to all of our listeners, especially the number of them that we have that listen every week, and a decent group of them that listen live every week. We love you all, and thanks for the support. Definitely share the show with coworkers and friends. We are at GoTimeFM on Twitter. If you find us on github.com/GoTimeFM/ping, please let us know topics or guests that you'd love to see on the show. And I think that's it. That's a wrap. Goodbye, everybody. We'll see you next week.
All right, that's it for this week's episode of Go Time. I hope you enjoyed it. Do us a favor, go on Overcast, go on Apple Podcasts, go on wherever you're listening to this podcast. Favorite it, share it, like it, tweet it, whatever you got to do. Help us promote this show to your friends and fellow Gophers. Bandwidth for Go Time and Changelog is provided by Fastly. Head to fastly.com to learn more. And we move fast here at Changelog and fix things because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode servers. Head to linode.com/changelog. Check them out. Support this show. Our music is produced by Breakmaster Cylinder. And you can find more shows just like this at changelog.com or on Apple Podcasts or on Overcast or wherever you subscribe to podcasts. Thank you for tuning in, and we'll see you next week.